Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 9.7, factoring difference of two squares. A little warm up. Let's multiply the binomials. Here I'm going to have to use double distribution, so it'll be x times x, x squared, x times negative 7, which is negative 7x. 7 times x is positive 7x, and 7 times negative 7 is negative 49. In this case, my negative 7x, my positive 7x will cancel, so I'm left with x squared minus 49. Part B says factor the binomial. Well, we just figured out how to go from using double distribution to get to a polynomial or a binomial. So now it's asking us to go back the other way. Well, as you can see, if I go back to what I was doing originally, I would end up with x plus 7 times x minus 7. Let's figure out how I actually did that. Okay. The first rule of factoring, though, is our GCF. Always look for a greatest common factor before we ever do anything, because if there's a greatest common factor, it will make our factoring much easier. Okay. The English translation of difference of two squares is the subtraction of two perfect squares. What I mean by perfect squares is if I have an x squared, it would take an x times an x to get me x squared, which means that it is in fact a perfect square. Same goes for something along the lines of x to the 12th, because I can take x to the 6th times x to the 6th to get me to x to the 12th. All right. So recognition, whether or not we are looking at something that is the difference of two squares or not. So label the following yes for the difference of two squares, or no if it is not, and then explain. So I have 9x squared minus 1. Is 9 a perfect square? Well, yes it is, because it's 3 times 3. X squared, is that a perfect square? Yes, because it's x times x. And 1, is that a perfect square? Yes, because it's 1 times 1 will get me to 1. So this is the difference of two squares. On to the second one, I have x to the 4th. Can I multiply by itself, anything by itself, to get me to x to the 4th? X squared and x squared. And 64, we should all know that that is the perfect square that gets me to 64 is 8. So 8 times 8 will get me to 64. On to the next one, x to the 10th. Is there anything I can multiply by itself to get me to x to the 10th? Well, yes, I can go x to the 5th times x to the 5th. 16, everyone should know that the square root of 16 is 4, which means 4 times 4 will get me to 16. So this is as well. The next one is x squared minus 7, or not 7, x squared minus y to the 4th. Obviously, x squared is a perfect square. Y to the 4th, I can use y squared times y squared. So this is as well the difference of two squares. The last one, I have x squared, or 9x squared and y to the 8th. Well, 9x squared is a perfect square, because I can make 3x times 3x will get me to 9x squared. Y to the 8th is also a perfect square, because y to the 4th times y to the 4th will get me y to the 8th. However, the key word here is difference. I do not have the difference of two squares because I have a plus sign. So no, this is not subtraction. If it's not subtraction, I do not have the difference of two squares, and I cannot, in fact, factor that. Okay? Now, when factoring a difference of two squares, there will be two terms in the polynomial. We should all know that the name of that is a binomial. Any polynomial that has two terms is a binomial. So steps for factoring difference of two squares. First, we're going to make two sets of parentheses. In one set of parentheses, we're going to put a positive. In the other, we're going to put a negative. Okay? Then, to fill in the first blank, these first blanks right here. So I have two sets of parentheses. I have a positive and a negative. I'm going to fill in this blank and this blank by square rooting, or taking the square root of the first term, or what we like to call the A term. The next step, now that I have the square root of our A term in the first blank, I need to fill in my second blank. So I'm filling in this blank right here. I'm going to take the square root of the second term. Finally, to make sure that I did this right, we're going to check our answer by using FOIL, better known as double distribution. Okay? So let's look at example 1. I have an x squared. That is a perfect square. I have a 16. That is a perfect square. And I have a negative sign in between, which means that I have the difference of two squares. So what I'm going to do is make a little factor tree up here. But instead of making a full factor tree, I'm going to say what the square root of x squared is, which in this case is x. Then for 16, what is the square root of 16? It will be 4. So now that I know what the square root of my two terms are, I can go ahead and make my two sets of parentheses, put a positive sign in one, a negative sign in the other. In the first blank, I'm going to put x and x because I use the square root of my first term. In my second blank, I'm going to put 4 and 4 because I use the square root of my second term. In order to check my answer, I need to use FOIL. So x times x is x squared. X times negative 4 is negative 4x. 4 times x is positive 4x. And 4 times negative 4 is negative 16. The negative 4x and positive 4x will cancel, so x squared minus 16 is my answer, which was my original problem, which means that my answer is x plus 4, x minus 4. That is the fully factored form. On to example 2. Before we ever get started, the first rule of factoring is always a GCF. Another way that you can think about this is the fact that 3 is not a perfect square. So I might want to try to figure out something I can take out of this binomial in order to get me the difference of two squares. So if I take out a 3, I have 3x squared divided by 3 leaves me with x squared. Negative 75 divided by 3 leaves me with negative 25. Well, the square root of x squared is x. The square root of 25 is 5. So I do have the difference of two squares here. I cannot forget to bring down my GCF, though. Remember, I can set up two sets of parentheses, a positive and a negative. The square root of my first term is x. The square root of my second term is 5. That will be my answer. In order to check this, I need to take x times x, which is x squared. X times negative 5 is negative 5x. 5 times x would be positive 5x. And 5 times negative 5 would get me negative 25. Cancel out the negative 5x, cancel out the positive 5x. X squared minus 25 is what I'm looking for after I do double distribution in order to find out if I factored correctly. So my answer is 3 times x plus 5 times x minus 5. On to example 3. Let's see if I have the difference of two squares to start with. 9 is a perfect square, x squared is a perfect square, and 4 is a perfect square, which means I do have the difference of two squares. So I'll set up two sets of parentheses, plus and minus. I need to figure out what is the square root of 9x squared. It'd be 3x. The square root of 4 is 2. So 3x and 3x, 2 and 2. Okay. If I use double distribution, I would take 3x times 3x, which is 9x squared. 3x times negative 2 is negative 6x. 3x times positive 2 is positive 6x. And positive 2 times negative 2 is negative 4. Cancel, cancel. 9x squared minus 4 was my original problem, so I have factored correctly. Okay. On to our final example on the front side here. I have 4x to the fourth minus y squared. 4 is a perfect square. X to the fourth is a perfect square. And y squared is a perfect square. I also have a subtraction sign. Square root of 4x to the fourth would be 2x squared. Square root of y squared would just be y. Two sets of parentheses. Positive sign, negative sign. 2x squared goes in the front. Y goes in the back. Now, if I multiply this out using double distribution, 2x squared times 2x squared would get me 4x to the fourth. 2x squared times y would get me negative 2x squared y. Y times 2x squared would get me positive 2x squared y. And y times negative y would get me negative y squared. Get rid of that. Get rid of that, including that y. I have 4x to the fourth minus y squared, which is my original problem. So that means I have factored this correctly. Okay? Let's go ahead and go to the back. Factor each polynomial completely. What I would like you to do is go ahead and try these 6 problems on your own. When you come into school tomorrow, we will go ahead and work through some of these. Just remember that I'm looking for any GCF. I want to make sure that I have the difference of 2 squares. If I do, I can set up 2 sets of parentheses. I will fill in the first blank with the square root of my first term. I will fill in the second blank with the square root of my second term. And you have to make sure that it is the difference of 2 squares. I cannot have the sum of 2 squares. Okay. Otherwise, thank you very much for watching the video. If you have any questions over this stuff, please come in and see me. Otherwise, thank you very much and have a great day.